Pedram, welcome to Talk Python to me. It's amazing to have you here.
Michael, great to be here.
Yeah, get to talk about data pipelines, automation, and boy, oh boy, let me tell you, have I been in the DevOpsy side of things this week. And I'm going to have a special appreciation of it. I can tell already. So excited to talk. Indeed. So before we get to that, though, before we talk about Dagster and data pipelines and orchestration more broadly, let's just get a little bit of background on you. Introduce yourself for people. How did you get into Python and data orchestration and all those things?
Of course, yeah. So my name is Pedram Navid. I'm the head of data engineering and DevRel at Dagster. That's a mouthful. And I've been a longtime Python user since 2.7. And I got started with Python like I do with many things, just out of sheer laziness. I was working at a bank and there was this rote task, something involving going into servers, opening up a text file and seeing if a patch was applied to a server. A nightmare scenario when there's 100 servers to check and 15 different patches to confirm.
Yeah, so this kind of predates like the cloud and all that automation stuff, right? So
this is definitely before cloud. This was like right between Python 2 and Python 3, and we were trying to figure out how to use print statements correctly. That's when I learned Python. I was like, there's got to be a better way. And honestly, I've not looked back. I think if you look at my entire career trajectory, you'll see it's just punctuated by finding ways to be more lazy in many ways.
Yeah. Who was it? I think it was Matthew Rockland that had the phrase something like productive laziness or something like that. Yes. Like, I'm going to find a way to leverage my laziness to force me to build automation so I never, ever have to do this sort of thing again. Like that sort of principle.
It's very motivating to not have to do something. And I'll do anything to not do something.
Yeah. It's incredible. And like that DevOps stuff I was talking about, and just, one command and there's maybe 8 or 9 new apps with all their tiers redeployed, updated, resynced. And it took me a lot of work to get there, but now I never have to think about it again, at least not for a few years. And it's amazing. I can just be productive. It's like right in line with that. So what are some of the Python projects you worked on? Talked about different ways to apply this over the years.
Oh yeah. So it started with internal, just like Python projects, trying to automate, like I said, some rote task that I had. And that accidentally becomes, a bigger project. People see it and they're like, oh, I want that too. And so, well, now I have to build like a GUI interface because most people don't speak Python. And so that got me into PyGUI, I think it was called, way back when. That was a fun journey. And then from there, it's really taken off. A lot of it has been mostly personal projects. Trying to understand open source was a really big learning path for me as well. Really being absorbed by things like SQL Alchemy and requests back when they were coming out. Eventually, it led to more of a data engineering type of role, where I got involved with tools like Airflow and try to automate data pipelines instead of patches on a server. That one day led to, I guess, making a long story short, a role at Dagster, where now I contribute a little bit to Dagster. I work on Dagster, the core project itself, but I also use Dagster internally to build our own data pipelines.
Mm-hmm. I'm sure it's interesting to see how you all both build Dagster and then consume Dagster.
Yeah, it's been wonderful. I think there's a lot of great things about it. One is like getting access to Dagster before it's fully released, right? So internally we dog food new features, new concepts, and we work with the product team, the engineering team, to say, hey, this makes sense, this doesn't, this works really well, that doesn't. And that feedback loop is so fast and so iterative that, like, for me personally, being able to see that come to fruition is really, really compelling. But at the same time, it's like I get to work at a place that's building a tool for me, right? You don't often get that luxury.
Yeah.
Right? I've worked in ads, I've worked in like insurance, it's like banking. It's like these are nice things, but it's not built for me, right? And so for me, that's probably been the biggest benefit, I would say.
Right. If you work in some marketing thing, you're like, I retargeted myself so well today. You wouldn't believe it. I really enjoyed it.
Yeah. No, I mean, I've seen ads that I've created before, so It's a little fun, but it's not the same.
Yeah. I've heard of people who are really, really good at ad targeting and finding groups where they've like pranked their wife or something, or just had an ad that would only show up for their wife by running it. It was like so specific and freaked them out a little bit.
Yeah, that's pretty clever. But I'm not there.
Yeah, maybe it wasn't appreciated, but it is clever.
Yeah.
Who knows? All right. Well, before we jump in, you said that, of course, you built GUIs with PyGUI and those sorts of things because people don't speak Python back then, 2.7 days and whatever. Is that different now? Not that people speak Python, but is it different in the sense that, like, hey, I could give them a Jupyter notebook, or I could give them Streamlit, or one of these things, right? Like a little more or less you build it and just like plug it in.
I think so. I mean, it's like you said, it's not different in that most people probably still to this day don't speak Python.
Yeah.
And I know we had this like movement a little bit back where everyone was going to learn like SQL and everyone was going to learn to code.
Mhm.
And I was never that bullish on that trend because, like, if I'm a marketing person, I've got 10,000 things to do, and learning to code isn't going to be the priority ever. So I think building interfaces for people that are easy to use and speaks well to them is always useful. That never has gone away. But I think the tooling around it has been better, right? I don't think I'll ever want to use PyGUI again. And nothing wrong with the platform. It's just like not fun to write. Streamlit makes it so easy to do that. So does like something like Retool, and there's like 1,000 other ways
Mhm.
now that you can bring these tools in front of your stakeholders and your users that just wasn't possible before.
I think it's a pretty exciting time. There are a lot of pretty polished tools.
Yeah, it's gotten so good.
Yeah. There's some interesting ones like OpenBB. Do you know that? The financial dashboard thing?
I've heard of this. I haven't seen it though.
Yeah,
No.
it's basically for traders, but it's like a terminal type thing that has a bunch of matplotlib and other interactive stuff that pops up, kind of compared to, say, Bloomberg dashboard
Oh,
type
okay.
things. But yeah, like that's one sense where like maybe like traders go and learn Python because it's like, all right, there's enough value here. But in general, I
Yeah.
don't think people are gonna stop what they're doing and learning the code. So these new UI things are not. All right, let's dive in and talk about this this general category first of data pipelines, data orchestration, all those things. And we'll talk about Dagster and some of the trends and that. So I just grabbed some random internet search for what is a data pipeline maybe look like. But people out there listening who don't necessarily live in that space, which I think is honestly many of us, maybe we should, but maybe in our minds we don't think we live in data pipeline land. Like tell them about it.
Yeah, for sure. It is hard to think about if you haven't done or built one before. Um, i- in many ways, a data pipeline is just a series of steps that you apply to some data set that you have in order to transform it to something a little bit more valuable at the very end. That's a simplified version. Um, the devil's in the details, but really, like at the end of the day, you're in a business. The production of data sort of happens by the very nature of operating that business. It tends to be the core thing that all businesses have in common. And then the other sort of output is you have people within that business who are trying to understand how the business is operating. And this used to be easy when all we had was a single spreadsheet that we could look at once a month. I
Yeah.
think businesses have gone a little bit more complex in these days. Computers,
And the
automation.
expectation, like they expect to be able to see almost real time, not I'll see it at the end of the month sort of
That's right.
data, right?
And
Yeah.
I think people have gotten used to getting data too, which is both good and bad. Good in the sense that now people are making better decisions. Bad, and then there's more work for us to do, and we can't just sit on our feet for half a day, half a month, waiting for the next request to come in. There's just an endless stream that seems to never end. So that's what really the pipeline is all about. It's like taking these data and making it consumable in a way that users, tools will understand. That helps people make decisions at the very end of the day. That's sort of the nuts and bolts of it.
In your mind, does data acquisition live in this land? So, for example, maybe we have a scheduled job that goes and does web scraping, calls an API once an hour. and that might kick off a whole pipeline of processing. Or we watch a folder for people to if upload over FTP, like a CSV file or something horrible like that. You don't even, it's unspeakable, but something like that where you say, oh, a new CSV has arrived for me to get, right?
Yeah, I think that's the beginning of all data pipeline journeys in my mind, very much, right? Like, and FTP, as much as we hate it, it's not terrible. I mean,
Nah.
there are worse ways to transfer files, but it's I think still very much in use today, and every data pipeline journey at some point has to begin with that consumption of data from somewhere.
Yeah, hopefully it's SFTP, not just straight FTP. Like the encrypted. Don't just send your password in the plain text.
Yep.
Oh well, yeah, I've seen that go wrong. That's a story for another day, honestly. All right, well, let's talk about the project that you work on. We've been talking about it in general, but let's talk about Dagster. Like, what is it? Where does it fit in this world?
Yes, Dagster to me is a way to build a data platform. It's also a different way of thinking about how you build data pipelines. Maybe it's good to compare it with kind of what the world was like, I think, before Dagster and how it came about to be. So if you think of Airflow, I think it's probably the most canonical orchestrator out there. But there are other ways which people used to orchestrate these data pipelines. They were often task-based, right? Like I would download file, I would unzip file, I would upload file. These are sort of the words we use to describe the various steps within a pipeline.
Some of those little steps might be Python functions that you write. Maybe there's some pre-built other ones.
Yeah, they might be Python. Could be a bash script. Could be logging into a server and downloading a file. Could be hitting request to download something from the internet, unzipping it. Just a various, hodgepodge of commands that would run. That's typically how we thought about it. For more complex scenarios where your data is bigger, maybe it's running against a Hadoop cluster or a Spark cluster. The compute's been offloaded somewhere else. But the sort of conceptual way you tended to think about these things is in terms of tasks, right? Process this thing, do this massive data dump, run a bunch of things, and then your job is complete. With Airflow, or sorry, with Dagster, we kind of flip it around a little bit on our heads, and we say, instead of thinking about tasks, what if we flipped that around and thought about the actual underlying assets that you're creating? What if you told us not, the steps that you're going to take, but the thing that you produce? Because it turns out, as people and as data people and stakeholders, really, we don't care about the task. Like, we just assume that you're going to do it. What we care about is, that table, that model, that file, that Jupyter notebook. And if we model our pipeline through that, then we get a whole bunch of other benefits. And that's sort of the Dagster sort of pitch, right? Like, if you want to understand the things that are being produced by these tasks, tell us about the underlying assets. And then when a stakeholder says and comes to you and says, how old is this table? Has it been refreshed lately? Well, you don't have to go look at a specific task and remember that task ABC had model XYZ. You just go and look up model XYZ directly there, and it's there for you. And because you've defined things in this way, you get other nice things like a lineage graph. You get to understand how fresh your data is. You can do event-based orchestration and all kinds of nice things that are a lot harder to do in a task world.
Yeah, more declarative, less imperative, I suppose.
Yeah, it's been the trend, I think, in lots of tooling. React, I think, was famous for this as well, right? In many ways.
Yeah.
It was a hard framework, I think, for people to sort of get their heads around initially, because we were so used to like the jQuery declarative or jQuery style of doing things.
Yeah. How do I hook the event that makes the thing happen?
Right.
Yeah.
And React said, let's think about it a little bit differently. Let's do this event-based orchestration, really. And I think the proof's in the pudding. React's everywhere now, and jQuery maybe not so much.
Yeah. There's still a lot of jQuery out there, but there's not a lot of active,
Yes.
not a lot of active jQuery. But I imagine there's some.
There it is. There's, yes.
Yeah, just because people like, you know what? Don't touch that. That works.
Which is probably the smartest thing people can do, I think. A lot of times.
Honestly, even though new frameworks are shiny, and if there's any ecosystem that loves to chase the shiny new idea. It's the JavaScript web world.
Oh
right?
yeah, there's no shortage of new frameworks coming out every day.
No, I mean, we do too, but not as much as like that's 6 months old. That's so old we can't possibly do that anymore. We're rewriting it. We're gonna do the big rewrite again.
Hmm. Yep.
Fun. Okay, so Dagster is the company, but also is open source. What's the story
Yeah,
around like? Can I use it for free? Is it open source? Do I pay for it?
100%.
Okay.
So Dagster Labs is the company. Dagster open source is the product. It's 100% free. We're very committed to the open source model. Um, I would say 95% of the things you can get out of Dagster are available through open source, and we tend to try to release everything through that model.
Mhm.
You can run very complex pipelines, and you can deploy it all on your own if you wish. There is a Dagster Cloud product, which is really the hosted version of Dagster. If you want a hosted plane, we can do that for you through Dagster Cloud. But it all runs on the same code base, and the modeling and the files all essentially look the same.
Mhm. Okay. So obviously, you could go like I talked about at the beginning. You could go down the DevOps side, get your own open source Dagster set up, schedule it, run it on servers, all those things. But if we just wanted something real simple, we could just go to you guys and say, "Hey, I built this with Dagster. Will you run it for me?"
Pretty much, yeah. Right. So there's two options there. You can do the serverless model, which says, Dagster, just run it. We take care of the compute, we take care of the execution for you, and you just write the code and upload it to GitHub or
Mhm.
any repository of your choice, and we'll sync to that and then run it. The other option is to do the
Oh, that's
hybrid
nice.
model.
So, sorry. So you basically do the CI/CD aspect. You just say you push to you name your branch. If you push
Yeah,
to that branch, that means we're just going to deploy a new version, and whatever happens after that, it'll be in production, right?
exactly. Yeah, and we offer some templates that you can use in GitHub for workflows in order to accommodate that.
Excellent. Then I cut you off. You're saying something about hybrid.
Hybrid is the other option for those of you who want to run your own compute. You don't want the data leaving your ecosystem. You can say, we've got this Kubernetes cluster, this ECS cluster, but we still want to use the Dagster Cloud product to sort of manage the control plane. Dagster Cloud will do that, and then you can go off and execute things on your own environment if that's something you wish to do.
Oh yeah, that's pretty clever because running stuff in containers isn't too bad, but running container clusters, all of a sudden you're back doing a lot of work, right?
Exactly. Yeah.
Yeah. Okay, well, let's maybe talk about Dagster for a bit. Then I want to talk about some of the trends as well. But let's just talk through maybe setting up a pipeline. Like, what does it look like? You talked about it in general, less imperative, more declarative. But what does it look like? Be careful about talking about code on audio, but
Oh, yeah.
just give us a sense of what the programming model feels like for us.
As much as possible, it really feels like just writing Python. It's pretty easy. You add a decorator on top of your existing Python function that does something. That's a simple decorator called asset, and then your pipeline, that function becomes a data asset. That's how it's represented in the Dagster UI. So you could imagine you've got a pipeline that gets like maybe Slack analytics and uploads that to
Mhm.
some dashboard, right? Your first pipeline, your function would be called something like Slack data, and that would be your asset. In that function is where you do all the transform, the downloading of the data until you've really created that fundamental data asset that you care about. And then that could be stored either, data warehouse to S3, however you sort of want to persist it. That's really up to you. And then the resources is sort of where the power, I think, of a lot of Dagster comes in. So the asset is sort of like declaration of the thing I'm going to create.
Mhm.
The resource is how I'm going to, operate on that, right? Because sometimes you might want to have let's say, a DuckDB instance locally because it's easier and faster to operate. But when you're moving to the cloud, you want to have a Databricks or a Snowflake. You can swap out resources based on environments, and your asset can reference that resource. And as long as it has that same sort of API, you can really flexibly change between where that data is going to be persisted.
Does Dagster know how to talk to those different platforms? Does it like natively understand DuckDB and Snowflake?
Yeah, so it's Interesting. People often look to Dagster and like, oh, does it do X? And the
Yeah,
question is like, Dagster does anything you can do Python with,
which is
um,
most things. Yeah.
which is most things. So I think if you come from the Airflow world, you're very much used to like these Airflow providers. And if you want
Yes,
to
that's kind of
use,
what I was thinking. Yeah.
yeah, you want to use a Postgres, you need to find the Postgres provider. You want to use S3, you need to find the S3 provider. With Dagster, you kind of say you don't have to do any of that. If you want to use Snowflake, for example, you install the Snowflake connector package from Snowflake, and you use that as a resource directly. And then you just run your SQL that way. There
Yeah.
are some places where we do have integrations that help, if you want to get into the weeds, with IO managers, where we persist the data on your behalf. And so for S3, for Snowflake, for example, there's other ways where we can persist that data for you. But if you're just trying to run a query, you're just trying to execute something, just trying to save something somewhere, you don't have to use that system at all. You can just use whatever Python package you would use anyway to do that.
So maybe some data is expensive for us to get as a company. Like maybe we're charged on a usage basis or it's super slow or something. I could write just Python code that goes and say, well, look in my local database. If it's already there, use that and it's not too stale. Otherwise, then do actually go get it, put it there and then get it back. And like that kind of stuff would be up to me to put together.
Yeah, and that's the nice thing, is you're not really limited by like anyone's data model or worldview on how data should be retrieved or saved or augmented. You could do it a couple of ways. You could say, whenever I'm working locally, uh, use this, persistent data store that we're just going to use
Yeah.
for development
A
purposes.
fancy database called SQLite, something like that.
Exactly. Yes, a wonderful database, and
It actually is, yeah.
it'll work really, really well. And then you just say, when I'm in a different environment, when I'm in production, swap out my SQLite resource for name your favorite cloud warehouse resource, and go fetch that data from there. Or I want to use mini IO locally. I want to use S3 on prod. It's very
Mhm.
simple to swap these things out.
Okay. Yeah, so it looks like you build up these assets, as y'all call them, these pieces of data, Python code that accesses them, and then you have a nice UI that lets you go and build those out, kind of workflow style, right?
Yeah, exactly. This is where we get into the wonderful world of DAGs, which stands for Directed Acyclic Graph, I think. It stands for a bunch of things that are not connected in a circle, but are connected in some way. So there can't be any
Right.
loops, right? Because then you never know where to start or where to end.
Could
But
be a
essentially, there's
diamond,
this,
but not a
could be
not a
diamond, yeah,
circle, right?
not a circle. As long as there's like a path through this data set with a beginning and an end, then we can kind of start to model this connected graph of things. And then we know how to execute them, right? We can say, well, this is the first thing we have to run because that's where all dependencies start. And then we can either branch off in parallel, or we can continue linearly until everything is complete. And if something breaks in the middle, we can resume from that broken spot.
Okay, excellent. And is that the recommended way? Like if I write all this Python code that works on the pieces, then the next recommendation would be to fire up the UI and start building it? Or do you say, you should really write it in code and then you can just visualize it or monitor it?
Everything in Dagster is written as code. The UI reads that code and it interprets it as a DAG, and then it displays that for you. There are some things to do in the UI, like you can materialize assets, you can make them run, you can do backfills, you can view metadata, you can sort of enable and disable schedules. But the core, we really believe this is Dagster, like the core declaration of how things are done, it's always done through code.
Okay, excellent. So when you say materialize, maybe I have an asset, which is really a Python function I wrote that goes and pulls down a CSV file. The materialize would be, I want to see kind of representative data in this in the UI. And so I could go, all right, I think this is right. Let's keep passing it down. Is that what that means?
Materialize really means just run this particular asset, make this asset new again, fresh again, right?
Yeah.
As part of that materialization, we sometimes output metadata, and you can kind of see this on the right if you're looking at the screen here, where we talk about what the timestamp was, the URL. There's a nice little graph of like number of rows over time. All that metadata is something you can emit, and we emit some ourselves by default with the framework. And then as you materialize these assets, as you run that asset over and over again over time, we capture all that, and then you can really get a nice overview of this asset's lifetime essentially.
Nice. Yeah, I think the metadata is really pretty excellent, right? Over time, you can see how the data's grown and changed, and
Yeah, the metadata is really powerful, and it's one of the nice benefits of then being in this asset world, right? Because you don't really want a metadata on like this task that run. You want to know like uh, this table that I created, how many rows has it had every single time it's run? Because if
Mhm.
that number drops by like 50%, that's a big problem. Conversely, if the runtime is slowly increasing every single day, you might not notice it. But over a month or two, it went from a 30-second pipeline to 30 minutes. Maybe there's like a great place to start optimizing that one specific asset.
Right. And what's cool if it's just Python code, well, you know how to optimize that probably, right?
Hopefully, yeah.
Well, as much as you're gonna, yeah, you have all the power of Python, and you should be able to, as opposed to it's deep down inside some framework that you don't really control,
Exactly.
right? Yeah.
You use Python, you can benchmark it. You probably knew you didn't write it that well when you first started, and you can always find ways to improve it.
Hmm. So this UI is something that you can just run locally, kind of like Jupyter.
100%. Just type
Hmm.
Dagster dev, and then you get the full UI experience. You get to see the runs, all your assets.
Is it a web app?
It is, yeah. It's a web app. There's a Postgres backend, and then there's a couple of services that run the web server, the GraphQL, and then the workers.
Nice. Yeah. So pretty serious web app, it sounds like. But
Yeah,
you
it's not
probably
something
just
I can
run it
write.
all. Yeah, yeah, just something you run all probably containers or something you just fire up when you download it, right?
Locally, it doesn't even use containers. It's just all pure Python for that. But
Nice.
once you deploy, yeah, I think might want to go down the container route. But it's
Sure.
nice not having to have Docker just to like run a simple test deployment, for example.
Yeah, I guess not everyone's machine has that for sure. So, question from the audience here. Jazzy asks, does it hook into AWS in particular? Is it compatible with existing pipelines like ingestion lambdas or transform lambdas?
Yeah, you can hook into AWS. So we have some AWS integrations built in. Like I mentioned before, there's nothing stopping you from importing Boto 3 and doing anything really you want. So a very simple use case, like let's say you already have an existing transformation that's being triggered in AWS through some Lambda. You could just model that within Dagster and say, trigger that Lambda through Boto
Mhm.
3. And
Okay.
then the asset itself is really that representation of that pipeline, but you're not actually running that code within Dagster itself. That's still occurring on the AWS framework. And that's a really simple way to start adding a little bit of observability and orchestration to existing pipelines.
Okay. That's pretty cool because now you have this nice UI and these metadata and this history, but it's someone else's cloud.
Exactly. Yeah.
Yeah.
And you can start to pull more information in there. And over time, you might decide, this, Lambda that I had, it's starting to get out of hand. I want to kind of break it apart into multiple assets where I want to sort of optimize it a little way. And Dagster can help you along that really well.
Hmm. Yeah. Excellent. How do you set up like triggers or observability inside Dagster? Like Jazzy's asking about S3, but like in general, right? If a row is entered into a database, something is dropped in a blob storage or the date changes. I don't know.
Yeah, no, these are great questions. So you have a lot of options. In Dagster, we do model every asset with a couple uh, little flags, I think, that are really useful to think about. One is whether the code of that particular asset has changed, right? And then the other one is
Hmm.
whether anything upstream of that asset has changed. And those two things really power a lot of automation functionality that we can get downstream. So let's start with I think the S3 example is the easiest to understand. You have a bucket and there is, a file that gets uploaded every day. You don't know what time that file gets uploaded. You don't know when it'll be uploaded, but at some point it will be. In Dagster, we have a thing called the sensor, which you can just connect to an S3 location. You can define how it looks into that file or into that folder. And then you would just pull every 30 seconds until something happens. When
Nice.
that something happens, that triggers sort of an event, and that event can trickle at your will downstream to everything that depends on it as you sort of connect to these things. So it gets you awake from this like, oh, I'm going to schedule something to run every hour, and maybe the data will be there, but maybe it won't. And you can have a much more event-based workflow. When this file runs, I want everything downstream to know that this data has changed. And as sort of data flows through these systems, everything will sort of work its way down.
Yeah, I like it. The sensor concept is really cool because I'm sure that there's a ton of cloud machines that people have provisioned just because this thing runs every 15 minutes, that runs every 30 minutes, and you add them up, and in aggregate, we need 8 machines just to handle the automation rather than, because they're hoping to catch something without too much latency, but maybe like
Yep.
that actually only changes once a week.
Exactly. And I think that's where we have to like sometimes step away from the way we're so used to thinking about things. And I'm guilty of this. When I create a data pipeline, my natural inclination is to create a schedule where I'd say, is this a daily one? Is this weekly? Is this monthly? But what I'm finding more and more is when I'm creating my pipelines, I'm not adding a schedule. I'm using Dagster's auto materialize policies, and I'm just telling it, you figure it out. I don't have to think about schedules. Just figure out when the things should be updated. When it's, parents have been updated, you run. When the data has changed, you run. And then just like figure it out and leave me alone.
Yeah.
And it's worked pretty well for me so far.
I think it's great. I have a refresh the search index on the various podcast pages that runs, and it runs every hour, but the podcast ships weekly, right?
Right.
But I don't know which hour it is, and so it seems like that's enough latency, but it would be way better to put just a little bit of smarts, like what was the last date that anything changed? Was that since the last time you saw it? Maybe we'll just leave that alone, But yeah, you're starting to inspire me to go write more code, but pretty cool. All right. So on the homepage at Dagster.io, you've got a nice graphic that shows you both how to write the code, like some examples of the code, as well as how that looks in the UI. And one of them says to launch backfills. What is this backfill thing?
Oh, this is my favorite thing.
Okay.
So when you first start your data journey as a data engineer, you sort of have a pipeline, you build it, and it just runs on a schedule, and that's fine. What you soon find is, you might have to go back in time, right? You might say, I've got this data set that updates monthly. Here's a great example, AWS cost reporting, right? AWS will send you some data around, all your instances and your S3 bucket, all that, and it'll update that data every day or every month or whatever have you. Due to some reason, you got to go back in time and refresh data that AWS updated due to some like discrepancy. Backfill is sort of how you do that. And it works hand in hand with this idea of a partition. A partition is sort of how your data is naturally organized, and it's like a nice way to represent that natural organization. It has nothing to do with like the fundamental way, how often you want to run it. It's more around like, I've got a data set that comes in once a month, it's represented monthly. It might be updated daily, but it's the representation of the data is monthly, so I will partition it by month. It doesn't have to be dates. It could be strings. It could be a list. You could have a partition for every, company or every client or, every domain you have. Whatever you sort of think is a natural way to think about breaking apart that pipeline. And once you do that partition, you can do these nice things called backfills, which says, instead of running this entire pipeline on all my data, I want you to pick that 1 month where data went wrong, or that 1 month where data was missing, and just run the partition on that range. And so you limit the compute, you save resources and get a little bit more efficient, and it's just easier to like think about your pipelines now because you've got this natural built-in partitioning system.
Mm-hmm. Excellent. So maybe you missed some important event. Maybe your automation went down for a little bit, came back up. You're like, oh no, we've missed it, right? But you want to start over.
You don't want to
like
start
3
over.
years. So like maybe we could just go and run the last day. It's worth of.
Exactly. Or
Okay.
another one would be your vendor says, hey, by the way, we actually screwed up. we uploaded this file from 2 months ago, but the numbers were all wrong.
Yeah.
We've uploaded a new version to that destination. Can you update your data set? One
Sure.
way is to recompute the entire universe from scratch. But if you've partitioned things, then you can say, no, limit that to just this one partition for that month. And that one partition can trickle down all the way to all your other assets that depend on that one.
Do you have to decide? Do you have to think about this partitioning beforehand, or can you do it retroactively?
You could do it retroactively, and I have done that before as well. It really depends on where you're at. I think if it's your first asset ever, probably don't bother with partitions, but it really isn't a lot of work to get them started.
Okay. Yeah, really neat. I like a lot of the ideas here. I like that it's got this visual component that you can see what's going on, inspect it. You also see you can debug runs. What happens there? Like, obviously, when you're pulling data from many different sources, maybe it's not your data you're taking in. Fields could vanish. They can be the wrong type. Systems can go down. I'm sure the debugging is interesting. So it looks a little bit kind of like a web browser debug dev tools thing.
So for the record, my code never fails. I've never had a bug in my life. But for those of you who have,
yeah, mine doesn't either. I only do it to make an example and to remind me how other. Yes, if I do, it's intentional, of course.
Yeah, to humble myself a little bit.
Exactly.
This view is one of my favorite. I mean, there's so many favorite views, but it's actually really fun to watch this actually run when you execute this pipeline. But really, like, let's go back to the world before orchestrators. We used cron, right? We'd have a bash script that would do something, and we'd have a cron job that said, make sure that this thing runs. And then hopefully it was successful, but sometimes it wasn't. And it's sometimes it wasn't. That's always been the problem, right? It's like, well, what do I do now? How do I know why it failed? When did it fail? At what point, at what steps did it fail? That's really hard to do. What this debugger really is a structured log of every step that's been going on through your pipeline, right? So in this view, there's 3 assets that we can kind of see here. One is called users, one is called orders, and one is to run dbt. So presumably there's these 2, tables that are being updated, and then a dbt job, it looks like, that's being updated at the very end. Once you execute this pipeline, all the logs are captured from each of those assets. So you can manually write your own logs. You have access to a Python logger, and you can use your info, your error, whatever have you, and log output that way, and it'll be captured in a structured way. But it also capture logs from your integrations. So if you're using dbt, we capture those logs as well. You can see it processing every single asset. So if anything does go wrong, you can filter down and understand at what step, at what point did something go wrong.
That's awesome. And just the historical aspect, because just going through logs, especially multiple systems, can be really, really tricky to figure out what's the problem, what actually caused this to go wrong. But come back and say, oh, it crashed, pull up the UI and see, all right, well, show me what this run did, show me what this job did. And
exactly.
It seems like it's a lot easier to debug than standard web API or something like that.
Exactly. You can click onto any of these assets that get that metadata that we had earlier as well. If one step failed and it's kind of flaky, you can just click on that one step and say, just rerun this. Everything else is fine. We don't need to restart from scratch.
Okay, and it'll keep like the data from before, so you don't have to rerun that.
Yeah, I mean, it depends on how you built the pipeline. We like to build idempotent pipelines, is how we sort of talk about it, the data engineering landscape, right? So you should be able to run something multiple times and not break anything. In a perfect world, that's not always possible. But ideally, yes. And so we can presume that if users completed successfully, then we don't have to run that again because that data was persisted, a database S3 somewhere. And if orders was the one that was broken, we can just only run orders and not have to worry about rewriting the whole thing from scratch.
Excellent. So idempotent, for people who maybe don't know, if you run it once, or you perform the operation once, or you perform it 20 times, same outcome. It should have side effects, right?
That's the idea. Yeah.
That's the idea.
Easier
We
said
can
than
strive
done
for it.
sometimes.
It sure is.
Sometimes it's easy, sometimes it's very hard. But the more you can build pipelines that way, the easier your life becomes in many ways.
Generally, not always, but generally true for programming as well, right? If you talk to
Yeah.
functional programming people, they'll say like it's an absolute, but
Yes. Yes. Functional programmers love this kind of stuff, and it actually does lend itself really well to data pipelines. Data pipelines, unlike maybe some of the software engineering stuff, it's a little bit different in that the data changing is what causes often most of the headaches, right? It's less so the actual code you write, but more the expectations tend to change so frequently and so often in new and novel and interesting ways that you would often never expect. And so the more you can sort of make that function so pure that you can provide it any sort of data set and really test really easily these expectations when they get broken, the easier it is to sort of debug these things and build on them in the future.
yeah, and cache them as well.
Yes, it's always nice.
Yeah. So speaking of that kind of stuff, like what's the scalability story? If I've got some big, huge, complicated data pipeline, can I parallelize them and have them run multiple pieces, like if there's different branches or something like that?
Yeah, exactly. That's one of the key benefits I think in writing your assets in this DAG way, right? Um, Anything that is parallelizable will be parallelized. Now, sometimes you might want to put limits on that. Sometimes too much parallelization is bad. Your poor little database can't handle it. And you can say, maybe a concurrency limit on this one just for today is worth putting on. Or if you're hitting an API for an external vendor, they might not appreciate 10,000 requests a second on that one. So maybe
Yeah.
you would slow it down. But in
Or
essence,
rate
anything,
limiting, right? You can run into
yeah,
too many requests, and then your
yeah,
stuff crashes. Then you got to start. It's like it can be a whole thing.
it could be a whole thing. There's memory concerns, but let's pretend the world is simple. Anything that can be parallelized will be through Dagster, and that's really the benefit of writing these DAGs is that there's a nice algorithm for determining what that actually looks like.
Yeah, I guess if you have a diamond shape or any sort of split, right? Those two things now become, because it's acyclical, they can't turn around and then eventually depend on each other again. So
Exactly.
that's a perfect chance to just go fork it out.
Exactly. And that's kind of where partitions are also kind of interesting. If you have a partitioned asset, you could take your data set, partition it into 5, buckets and run all 5 partitions at once, knowing full well that because you've written this in a uh, idempotent and partition way, that the first pipeline will only operate on, apples, and the second one only operates on bananas. And there's no commingling of apples and bananas anywhere in the pipeline.
Mm-hmm. Oh, that's interesting. I hadn't really thought about using the partitions for parallelism, but of course.
Yeah, it's fun. It's a fun little way to break things apart.
Mm-hmm. So if we run this on the Dagster cloud or even on our own, is this pretty much automatic? We don't have to do anything. Like Dagster just looks at it and says, this looks parallelizable, and it'll go. Or
That's right. Yeah. As long as you've got the full deployment, whether it's OSS or cloud, Dagster will basically parallelize it for you as much as possible.
excellent.
You can set global concurrency limits. So you might say, 64 is more than enough, parallelization that I need. Or maybe I want less because I'm worried about overloading systems, but
Right.
it's really up to you. You have that
I'm
control.
putting this on a $10 server. Please don't, please don't kill
Yeah.
it. Just respect that it's somewhat wimpy, but that's okay.
Yeah, it'll get the job done.
It'll get the job done. All right. I want to talk about some of the tools and some of the tools that are maybe at play here when working with Dagster and some of the trends and stuff. But before that, maybe speak to where you could see people adopt a tool like Dagster, but they generally don't. They don't realize like, oh, actually, there's a whole framework for this, right? Like I could go and build just on HTTP server and hook into the request and start writing to it. But like, maybe I should use Flask or Fast API. Like there's these frameworks that we really naturally adopt for certain situations like APIs, and others, background jobs, data pipelines, where I think there's probably a good chunk of people who could benefit from stuff like this, but they just don't think they need a framework for it. Like cron is enough.
Yeah. It's funny because sometimes cron is enough, and I don't want to encourage people not to use cron, but think twice at least is what I would say. So probably the first like trigger for me of thinking of is that actually a good choice is like, am I trying to ingest data from somewhere? Because that's something that fails. Like I think we just can accept that if you're moving data around, the data source will break, the expectations will change. You will need to debug it. You'll need to rerun it, and doing that in cron is a nightmare. So I would say definitely start to think about an orchestration system if you're ingesting data. If you have a simple cron job that sends one email, like you're probably fine. I don't
Yeah,
think you
sure.
need to implement all of Dagster just to do that. But the more closer you get to data pipelining, I think the better your life will be if you're not trying to debug a obtuse process that no one really understands 6 months from now.
Mm-hmm. Excellent. All right, maybe we could touch on some of the tools that are interesting that you see people using. You talked about DuckDB and DBT, a lot of D's starting here, but give us a sense of like some of the supporting tools you see a lot of folks using that are interesting.
Yeah, for sure. I think in the data space, probably DBT is one of the most popular choices. And DBT, in many ways, it's nothing more than a command line tool that runs a bunch of SQL in a DAG as well. So there's actually a nice fit with Dagster and DBT together. DBT is really used by people who are trying to model that business process using SQL against typically a data warehouse. So if you have your data in, for example, a Postgres, a Snowflake, um, Databricks, Microsoft SQL, these types of data warehouses, generally you're trying to model some type of business process, and typically people use SQL to do that. Now you can do this without DBT, but DBT has provided a nice clean interface to doing so. It makes it very easy to connect these models together, to run them, to have a development workflow that works really well, and then you can push it to prod and have things run again in production. So that's DBT.
Mm-hmm.
We find it works really well, and a lot of our customers are actually using DBT as well. There's DuckDB, which is a great. It's like the SQLite for columnar databases, right?
Yeah.
It's in process. It's fast. It's written by the Dutch. There's nothing you can't like about it. It's free. We love
It
that.
feels
So
very comfortable in Python itself.
it
because it's
does. It's
also
so
Dutch. Yeah.
easy. Yes, exactly. The Dutch have given us so much, and they've asked nothing of us. So I'm always very thankful for them. It's fast. It's so fast. It's like if you've ever used pandas for processing large volumes of data, you've occasionally hit memory limits or inefficiencies in doing these large aggregates. I won't go into all the reasons of why that is, but DuckDB sort of changes that because it's a fast serverless sort of C++ written tooling to do really fast vectorized work. And by that, I mean like it works on columns. So
Mm-hmm.
typically in like SQLite, you're doing transactions. You're doing single row updates, writes, inserts, and SQLite is great at that. Where typical transactional databases fail or aren't as powerful is when you're doing aggregates, when you're looking at an entire column, right? Just the way they're architected. If you want to know the average, the median, the sum of some large number of columns, and you want to group that by a whole bunch of things, you want to know the first date someone did something and the last one, those types of vectorized operations, DuckDB is really, really fast at doing. And it's a great alternative to, for example, pandas, which can often hit memory limits and be a little bit slow in that regard.
Mm-hmm. Yeah, it looks like it has some pretty cool aspects, transactions, of course, but it also says direct Parquet, CSV, and JSON querying. So if you've got a CSV file hanging around and you want to ask questions about it, or JSON, or some of the data science stuff through Parquet, turn a indexed proper query engine against it. Don't just use a dictionary or something, right?
Yeah, it's great for reading a CSV, zip files, tar files, parquets, partition parquet files, all that stuff that usually was really annoying to do and operate on. You can now install DuckDB. It's got a great CLI too. So before you go out and like program your entire pipeline, you just run DuckDB and you can start writing SQL against CSV files and all this stuff to really understand your data and just really see how quick it is. I used it on a bird data set that I had as an example project, and there was millions of rows, and I was joining them together and doing massive group buys, and it was done in like seconds, and it's just hard for me to believe that it was even correct because it was so
Yeah.
quick. So it's wonderful. It's
I
really
must have
good.
done that wrong somehow because it's done. It
Exactly.
shouldn't be done.
Yeah.
Yeah. And the fact it's in process means there's not a server for you to babysit, patch, make sure it's
Mhm.
still running. It's accessible, but not too accessible. All that, right?
It's a pip install away, which is always, we love that, right?
Yeah, absolutely. You mentioned, or I guess I mentioned Parquet, but also Apache Arrow seems like it's making its way into a lot of different tools and sort of foundational, sort of high performance in memory processing. Have you used this, Eddie?
I've used it, especially through like working through different languages. So moving data between Python and R is where I last used this, and Arrow's great at that. I believe Arrow is like the underneath some of the um, Rust to Python as well. It's working there. So typically, I don't use Arrow like directly myself, but it's in many of the tooling I use. It's
Right.
a great product, and like so much of the ecosystem is now built on Arrow.
Yeah, I think a lot of it is. I feel like the first time I heard about it was through Polars.
That's right. Yeah.
I'm pretty sure, which is another Rust story for kind of like Pandas, but a little bit more fluent, lazy API.
Yes. We live in such great times, to be honest. So, Polars is a Python bindings for Rust, I believe, is kind of how I think about it. It does all the transformation in Rust, but you've had this Python interface to it, and it makes things again incredibly fast. I would say similar in speed to DuckDB. They both are quite comparable sometimes. I
Yeah, it
believe
also
Arrow's
claims to have vectorized and columnar processing and all that kind of stuff.
yeah, it's pretty incredible. So not a drop-in replacement for Pandas, but if you have the opportunity to use it, and you don't need to use the full breadth of what Pandas offers, because Pandas is quite a huge package. There's a lot it does. But if you're just doing simple transforms, I think Polars is a great option to explore.
Yeah, I talked to Richie Vink, who was part of that, and I think they explicitly chose to not try to make it a drop-in replacement for Pandas, but try to choose an API that would allow the engine to be smarter. Go like, I see you're asking for this, but the step before you wanted this other thing, so let me do that transformation all in one shot. And a little bit like a query optimization engine.
Yeah.
Yeah. What else? What else is out there? We got time for just a couple more. If there's anything that you're like, oh yeah, people use this all the time. Obviously, the databases you've said, Postgres, Snowflake, etc.
Yeah, there's so much. So another little one I like is called DLT Hub. It's getting a lot of attraction as well. And what I like about it is how lightweight it is. I'm such a big fan of lightweight tooling that's not, massive frameworks. Um, Loading data is, I think, still kind of yucky in many ways. It's not fun. And DLT makes it a little bit simpler and easier to do so. So that's one I would recommend people just to look into if you got to
Okay.
either ingest data from some API, some website, some CSV file. It's a great way to do that.
It claims it's the Python library for data teams loading data into unexpected places. Yeah, very interesting.
Yes, that's great.
Yeah, this looks cool. All right. Well, I guess maybe let's talk business, and then we can talk about what's next, and then we'll probably be out of time. I'm always fascinated. I think there's starting to be a bit of a blueprint for this, but companies that take a thing, they make it and they give it away, and then they have a company around it. And congratulations to you all for doing that, right? And a lot of it seems to kind of center around the open core model, which I don't know if that's exactly how you would characterize yourself, but yeah, maybe just talk about the business side, because I know there's many successful open source projects that don't necessarily result in full-time jobs or companies if people were to want that.
Yeah, it's a really interesting place, and I don't think it's one that anyone has truly figured out well and can say this is the way forward for everyone. Um, but it is something we're trying, and I think for Dagster, I think is working pretty well. And um, w- what I think is really powerful about Dagster is like the open source product is really really good, and it hasn't really been limited in many ways in order to drive like cloud product consumption.
Yeah,
We really
sure.
believe that there's actual value in that separation of these things. There are some things that we just can't do in the open source platform. For example, there's pipelines on cloud that involve, ingesting data through our own systems in order to do reporting, which just doesn't make sense to do on the open source system. It make the product way too complex. But for the most part, I think Dagster open source, like we really believe that like just getting it in the hands of developers is the best way to prove the value of it. And if we can build a business on top of that, I think we're all super happy to do so. It's nice that we get to sort of drive both sides of it. To me, that's like one of the more exciting parts, right? Um, a lot of the development that we do in Dagster open source is driven by people who are paid through, what happens on Dagster Cloud. And I think, from what I can tell, there's no better way to build open source product than to have people who are adequately paid to develop that product. Otherwise, it can be, labor of love, but one that doesn't
Yeah.
last for very long.
Yeah. Whenever I think about building software, there's like 80% of it that's super exciting and fun. 10% is and then there's that little sliver of like really fine polish that if it's not just your job to make that thing polished, you're just, for the most part, just not going to polish that bit, right?
It's tough. UI,
Yeah.
design, support. There's all these things that go into making a software like really extraordinary. That's really, really tough to do. And I think I really like the open source business model. I think for me, being able to just try something, not having to talk to sales, and being able to just deploy it locally and test it out and see if this works. And if I choose to do so, deploy it in production. Or if I bought the cloud product and I don't like the direction Dagster is going, I can leave and go to open source as
Yeah.
well. That's pretty compelling to me.
Yeah, for sure it is. And I think the more moving pieces of infrastructure, more uptime you want and all those types of things, the more somebody who's maybe a programmer but not a DevOps infrastructure person but needs to have it there, right? Like that's an opportunity as well, right? For you to say, look, you can write the code. We made it cool for you to write the code, but you don't have to get notified when the server's down or whatever, right? Like we'll just take care of that for you. That's pretty awesome.
Yeah, and there's efficiencies of scale as well, right? Like we've learned the same mistakes
Yep.
over and over again, so you don't have to, which is nice. I don't know many people who want to maintain servers, but um, people do, and they're more than welcome to if that's how they choose to do so.
Mm-hmm. Yeah, for sure. All right, just about out of time. Let's close up our conversation with where are things going for Dagster? Like, what's on the roadmap? What are you excited about?
Oh, that's a good one. Um, I think we've actually published our roadmap online somewhere. If you search Dagster roadmap, it's probably
Mhm.
out there. I think for the most part, that hasn't changed much going into 2024, though we may update it. There it is. We're really just doubling down on what we've built already. I think there's a lot of work we can do on the product itself to make it, easier to use, easier to understand. My team specifically is really focused around the education piece. And so we launched Dagster University's first module, which helps you really
Okay.
understand the core like concepts around Dagster. Our next module is coming up in a couple months, and that'll be around using Dagster with DBT, which is our most popular integration. We're building out more integrations as well. So I've built a little integration called embedded ELT that makes it easy to ingest data. But I want to actually build an integration with DLT as well, DLT Hub. So we'll be doing that. And there's more coming down the pipe, but I don't know how much I can say. Look
Sure.
forward to an event in April where we'll have a launch event on all that's coming.
Nice. Is that an online thing people can attend or something like
Exactly. Yeah, there'll be some announcement there on the Dagster website on that. Maybe I will call it one thing that's actually really fun. It's called Dagster Open Platform. It's a GitHub repo that we launched a couple months ago, I want to say.
that? Mhm.
And we took our internal, I should go back one more. Sorry. It's like GitHub, Dagster Open Platform and GitHub.
I have it somewhere.
Yeah. If you go,
It's here
yeah,
under the
it's there.
organization.
Yes, it should be somewhere in here. There it is. Dagster Open Platform on GitHub. And it's really a clone of our production pipelines for the most part. There's some things we've, chosen to ignore because they're sensitive, but as much as possible, we've defaulted to making it public and open. And the whole
Mhm.
reason behind this was because, as data engineers, it's often hard to see how other data engineers write code. We get to see how software engineers write code quite often, but most people don't want to share their data platforms for various good reasons.
Right.
We've
Well,
tried to
also
change that.
there's like smaller teams or maybe just one person, and then like those pipelines are so integrated into your specific infrastructure, right? So it's not like, well, here's a web framework to share, right? Like here's how we
Yeah,
integrate into that one weird API that we have that no one else has. So it's no point in publishing it to you, right?
that's typically how it goes. Or they're so large that they're afraid that there's like some, important
Sure.
information that they just don't want to take the risk on.
Yep.
And so we built like something that's in the middle where we've taken as much as we can and we've publicized it. And you can't run this on your own. Like that's not the point. The point is to look at the code and see, how does
Mhm.
Dagster use Dagster and what does that kind of look like?
Nice. Okay. All right. Well, I'll put a link to that in the show notes and people can check it out.
Appreciate it.
Yeah, I guess let's wrap it up with the final call to action. People are interested in Dagster. How do they get started? What do you tell them?
Oh yeah, Dagster.io is probably the greatest place to start. You can try the cloud product. We have free self-serve, or you can try the local install as well. If you get stuck, a great place to join is our Slack channel, which is up on our website. There's even a Ask AI channel where you can just talk to a Slack bot that's been trained on all our GitHub issues and discussions, and it's surprisingly good at walking you through, any debugging, any issues, or even advice. And
That's pretty excellent, actually.
yeah, it's real fun. It's really fun. And if that doesn't work, we're also there in the community where you can just chat to us as well. So
Cool. All right. Well, Pedram, thank you for being on the show. Thanks for all the work on Dagster and sharing it with us.
thank you, Michael.
You bet. See you later.